Hi, this is Andrew.
And Jesse.
And today we're going to cover 2015 AP Calc BC FRQ number 6. For this question, the Maclaurin series for function f is given. That's negative 3 to the n minus 1 power times x to the n over n. And that converges to f of x for absolute value of x is smaller than r, where r is the radius of convergence of the series. For a, we're going to use the ratio test to find r. The ratio test is limit of n approaches infinity, absolute value of a sub n plus 1 over a sub n. That equals absolute value of p. For the series to converge, absolute value of p should be smaller than 1. So from here, all we need to do is just plugging in the series into the ratio test. That gives us notice we drop the negative signs in both 3's here. This is because the ratio test doesn't need to care about the negativity of the series. By simplifying it further, we get and now we can actually evaluate the limit. So if you send that n to infinity, this whole thing turns into 1, which gives out 3 absolute value of x, which is the same thing with absolute value of 3x. And as I said, for the ratio test to converge, you need to set this as smaller than 1. So by dividing both sides by 3, we get absolute value of x is smaller than 1 over 3, which is the form that we were looking for. So r is equal to 1 over 3 here.
Part B asks us to write the first 4 non-zero terms of the Maclaurin series for f prime, the derivative of f. The first step to solving this is to find the first 4 non-zero terms of f. So we'll write them out here. It is important that we use an approximation symbol instead of an equal sign because this is an approximation. We're not writing out the whole series, only 4 terms. And if you look in the top, they already give us the first 3 terms of the series, so we'll just write these down here. X minus 3 has x squared plus 3x cubed. And to find the 4th term, you just have to plug in 4 for n, which you end up getting as negative 27 over 4x to the 4th. So now that we have the first 4 terms of f, we have to find the first 4 non-zero terms of f prime. And this is simply find the derivative of each of the terms. Derivative of x is 1. Derivative of negative 3 halves x squared is negative 3x. And so on for the rest of them. There you have the first 4 non-zero terms of f prime. Then B asks us to express f prime as a rational function if the absolute value of x is less than r, which we know that r is 1/3. So we're expressing f prime as a rational function for absolute value of x is less than 1/3. And to express this as a rational function, you can look at the series of f prime and see that this is a geometric series because there's a common ratio between the terms. And this common ratio is negative 3x. If you times any of the terms by negative 3x, you will get the next term in the series, meaning it is geometric. So, to write a geometric series as a rational function, you will use the equation a over 1 minus r, which we have r already, the common ratio, and a is the first term in the series, which we can see is 1. Then you just plug in for a and r, and there you have f prime as a rational function for the absolute value of x is less than 1/3. For part C, we're asked to write the first 4 non-zero terms of the Maclaurin series for e to the x. You could solve this all out, but this is a Maclaurin series you should have memorized, which is, and once again, remembering to use the approximation symbol because this is only 4 terms, not the whole series. And then moving on to the next part of part C, we're asked to use the Maclaurin series for e to the x to write the 3rd degree Taylor polynomial for g of x is equal to e of x times f of x about x is equal to 0. What we do here is we multiply the series of e to the x by the series of f of x. So we'll write out both of the series here. It is important to remember that we're only solving for the 3rd degree Taylor polynomial, meaning we only need the first 3 terms, saving us a lot of extra multiplication. But what you should end up getting is, which, if you simplify that down, and you can write your final answer out as this.